Hello everyone, I'm Ajay Yadav, and in our previous video we have covered what are the different topics that we are going to cover in the algorithms, and today we are just starting with our first chapter, that is Introduction to Algorithms. Here the different topics that we are going to cover is first is we are going to cover about the algorithms, and then we will cover what are the real time use cases of the algorithms. Then we will understand how we do the algorithm analysis and why analysis is required. Then we will understand big O, big omega, and the big theta annotation for analyzing the algorithms. Then we will study about the different methods using which you can do the analysis of the algorithms, and then we will compare the different time complexity. So let's start with the first thing, that is our algorithm. So first question is, what is algorithm? So algorithm is series of steps to accomplish any task. So it is a series of steps to accomplish any task. Yeah, a task. So what is the example of this, right? So for example, you want to make a mango shake, and then you will have to do certain things. For example, first you have to peel off the mango, cut it into the smaller pieces, put it into the mixture, add milk, add sugar, then mix all these things, then pour your mango shake into the. This is the whole process for mango making the mango shake. That is its algorithm. Coming to take a more complex example, so let's say you want to build a car. So first you have to get the material, you have to build the frame out of it, and then you have to add the cars, you have to add the interiors, you have to add the engines, right? And do a lot of these things, then your car will be built out. So this is the algorithms for building a car, and this what we call the algorithm. But there are some conditions before we say it an algorithm. So for example, we talk about this step, right? So series of the steps, so the number of steps should be constant. So first condition is number of steps should be finite. Second condition, this steps will take some time, so the time taken by step should be finite. So these are the two conditions. First, the number of the steps that is involved in algorithm should be constant, and the time taken by any step should be constant. Then you will say, yes, this is my algorithms for doing anything. Now let's think about what are the real life use cases of the algorithm. So for example, you want to take a city. For example, you are currently in Delhi. You want to go to Hyderabad, and now there are the different routes. So for example, first route here goes through the Jaipur. Second route you go through, let's say, Lucknow, and there are some other routes through which you are going to the Hyderabad. But out of these, which path is the best, which take the lesser time, lesser cost to you in order to reach the Hyderabad? Which one you should choose, right? So this based on the algorithm. So generally we do it with the finding the shortest path algorithms. There are different algorithms. One of the most common register, but for sake of this, we are mentioning it as at a high level. That is the graph based algorithm. So this is the real type life use case for the algorithm. Now let's say you want to search for anything. So what are you going to search? So you are going to search a word, and you want to search, or you want to search for a phone number. So what do you search in the dictionary? Phone number you search in the directory, phone directory. And for these kind of algorithm, we use the search based algorithms. Now, for example, sometimes you need to arrange the things in the order. For example, I tell arrange the students according to their heights, arrange the products according to their weights. So for these kind of things, the sorting algorithms are being used for arrangement. So these are the some of the real life use cases, and yeah, definitely there are multiple algorithms which are being used in the different real life scenarios. So while we're studying individual algorithms, so we will cover their use cases at that particular period of time. Now, I understood about the algorithm analysis. So what is algorithm analysis? So let's first understand you have multiple algorithms present in order to solve a single problem. But out of these two algorithms, you have to find which one is efficient in terms of either the time complexity or the space complexity. So mostly we compare based on the time complexity, but if we have somewhere we have the space constraint, then we go with the space complexity as well. So algorithm analysis is to identify how fast your algorithm is. Algorithm is, and we will just mentioned either it is based on the time complexity or the space complexity we do. And now there are the two different types of analysis that we do. First is the priori, and the second is the posterior. What is the difference between these two? So first, priori is kind of your hardware independent. It means, for example, you can run algorithm anywhere, in Linux, Windows, with different CPU, different cores, and your algorithm should take the constant data amount, that time that is taken. So we don't measure it in the unit of time. For example, second, we measure it in the number of operations. If we coming in the posterior, so it is hardware dependent. So sometimes we need your algorithms to be optimized based on your machines, so this is hardware dependent. And here we compare it based on the amount of the time taken. So milliseconds, second, nanoseconds, seconds, so these are the units in which we compare the posterior annotations. Now there are the different annotations being used in order to compare the algorithms. So let's start with the first is the BIGO annotations. What is actually meaning of this particular algorithm? So let's start to understand this with a graph. So for example, you have given a function fn, and this function has some graph like this, and it is fn. Now you have to build if another function that is the gn. This is the gn function, and this function can go anywhere like this, but after a particular point of time, it will always be greater than the fn. So here the g. So actually, what it is telling you, it is telling the upper bound of algorithm. Sorry, this is some overlap between the content. Mm, Now this point we say it is the k. So we can say for all n greater than equal to k, your gn is greater than fn. Yeah, we can remove the equal to for n greater than the k. Now how we can write it? Fn is greater than equal to gn, not exactly gn, your c dot gn. So this is the thing. Sorry, I wrote it in other way around. Your c dot gn should be greater than. Now, take an example. For example, you have an example of 5n square plus 3n plus 1. Right, so what this is our fn, and similarly, what will be our gn. So you can always eliminate the terms like what is the smaller terms, because this is have the higher effect. So you can always remove this. And now, what is the greater than this? So your 6n square is always greater than f n square. So in this case, your c is 6 and your gn is n square. Now moving to the another example, that is the big omega. So here somewhere your this is your fn. Now this is somewhere this algorithm here the gn. So upper this algorithm, previous algorithm that we talk about the pico, it is giving you upper bound. This algorithm you gives you the lower bound, and lower bound represent your best case best case. And here, if you again look for here, For n greater than k, your fn should be greater than equal to your g of n, here the c of t. Now, what it exactly means or how it is actually represented, it is represented like this of g of. Now, coming to the big theta annotation. So, this is the graph, this is your fn, and it says that there are the two functions. So, your this is your g2 of n, and somewhere this is your g1 of n. Means, sorry, so it is, you can like g1 and as c g1 remove here, so you can use that one in the constant. So 2 here your g of n. Now your fn is lies between c2 of gn, and it lies between c1 of gn. So it is greater than c1 of gn and less than equal to c2 of gn, and this is represented as fn, and here theta of g. So these are the three representations in which your functions are being represented for algorithm analysis. And now in next chapter we will study about what are the different methods for doing the algorithm analysis and what is the order of the time complexity. I hope you enjoyed this lecture. Thank you.